All right, guys, so we're talking about 5.4. That should be B. You know what? I'm going to change it on the spot right now. Watch this. Right in front of you guys. I should already did this, but I didn't. We're talking about 5.4b, dividing polynomials by synthetic division. I can divide polynomials by utilizing synthetic division. What in the world is synthetic division? I know what synthetic motor oil is. What in the world is synthetic division? Well, I want to start with the problem we worked on yesterday. And y'all remember this probably. It's probably still etched in your mind. This is the last problem that we did yesterday by long division. And hopefully you were thinking in your heart and mind, there has got to be a better way to do this type of problem, okay? And so I want to show you what I believe is a better way. It's going to take a little bit of getting used to just because it's something we've never seen before. But I think once you get a hang of this, that you're actually going to find this to be a lot easier than what you did yesterday, okay? So I want to introduce you to synthetic division. And where we're going to start is, actually we're going to start with this little box, okay? We're actually going to make an even smaller box. We're going to work out this same exact problem, but we're going to do it through synthetic division, okay? One of the first things I want you to understand is what we're dividing by. We're dividing by x minus 3, okay? So if I take x minus 3 and I set that equal to 0, what does that actually become? Let's think about that for just a second. So that actually, we would have to add 3 to both sides, and so that actually means that x equals 3. If I put 3 in, that will make this equal 0. And you say, well, why is that important? Because this is actually the number that needs to go in the little box that we're going to create, okay? So the first thing you have to do is take your divisor, whatever you're dividing by, okay, and you're going to set that equal to 0. And again, it's just going to be the opposite, especially if it's like this, x minus 3 equals 0. It's just going to be the opposite. It's actually going to be a positive 3. So here's what we're going to do first. We're going to go ahead and do a positive 3 right here, and I'm going to put just this kind of box like this right here, okay? Now, what really makes the problem is really the numbers. Okay, it's not the variables. In other words, I could have had these as being A's, or I could have had them as being B's. It wouldn't have really made any difference. That is not really what makes the problem. What makes the problem is, in fact, the coefficients. Okay, so the coefficient here is actually a 1, even though I don't see it. The other coefficient in this problem is a negative 7. I have a positive 11, and I have a positive 3. Those are the numbers that actually make the problem, okay? So when you're talking about synthetic division, what you're going to do is you're going to just write out right beside of this, just the coefficients. And the key is this has to be in standard form. So you notice I'm starting with the third power, the second power, the first power, and then this has a 0 power, okay? So you have to be going in descending powers. It has to be in standard form in order to be able to do this. But again, it's going to be worth it, okay? So let's just write down these coefficients right here that we were talking about. We're going to write them down right here, just kind of in line with where we've already got the little box and the 3. So I'm going to bring down a 1, a negative 7, an 11, and a 3, okay? So essentially, there is my problem, okay? This represents x minus 3, right? Because I changed it to setting it equal to 0, whatever it was. This represents my coefficients. All of this stuff here is my coefficients in my problem. So that basically is my problem. Here's what I'm going to do. I'm going to leave a little bit of space, and I'm going to go ahead and put a line right here, okay? Now, the next thing I'm going to do, and this is what you do every single time, is I just go ahead and bring down this 1 just like it is, okay? So the first thing you do with synthetic division is to bring it down. After I bring it down, I'm going to go ahead and multiply whatever I bring down times this number that's in the box, okay? So I'm going to multiply this times whatever is in the box. So 1 times 3 is going to equal 3, and that 3 is going to go right here on my next line, okay? Now, the difference here, instead of with regular division, is I'm going to add everything that ends up coming on this line, okay? So first step, again, I multiplied whatever I brought down times what's in the box, okay? Then I simply put that number right here into the next line, and now I'm going to add, okay? So if I take negative 7 plus 3, I'm going to get negative 4. Now I'm going to take that number, negative 4, again, and I'm going to multiply it times the 3 that's in the box. So negative 4 times positive 3 is a negative 12. And again, I'm going to add. All right, maybe I need to make that a different color. I'm going to add. So then if I add negative 11 plus 12, I'm going to get a negative 1. Negative 1 times 3, there I am, I'm doing it again. I'm multiplying it times whatever's in the box. Negative 1 times 3 is a negative 3, and negative 3 plus 3 equals 0. Now you're thinking to yourself, this is just a bunch of numbers. Mr. Hamilton, this don't make a bit of sense. Okay, here's where this really, really gets cool. Notice when I started with this, I started with an x to the third, okay? And I started here with x squared, and then this was x, and this didn't have an x at all. All you have to do literally is all of these numbers here now are my new coefficients. The only difference is they drop down by 1 power. So in other words, instead of this being x to the third, it's actually x squared. Okay, I have a 1 there, but I really wouldn't even have to put that. Minus 4x, instead of x squared, it drops by 1 power, minus 1. And this, ladies and gentlemen, at the end is my remainder. So I have a remainder of 0. Now here's what I want you to do. This is a really magic moment right now. I want you to look at the answer that I just got through this little bit of work right here, and look at that answer compared to what I had right here. X squared minus 4x minus 1 with no remainder. Ladies and gentlemen, it's exactly the same answer that I got on the last one, okay? So this works every single time. And it also works when you are given a remainder, okay? So I actually want to look at another example here, but I want to look at an example. We'll look at 2 different ones here, I guess. Actually, I'm going to look at this one. All right, so I have 2x, let me get a different color off so we can use different colors. Let's look at 2x to the third minus 15x plus 23 divided by x minus 2. Now, there's a reason that I want to pick this problem. All right, we'll call this number 2. There's a reason I want to pick this problem because it has a very special situation here that we need to look at. So again, the first thing we need to do is look at what we're dividing by, which is x minus 2. So I'm going to take x minus 2 and I'm going to set it equal to 0, which means that I'm actually going to add 2 to both sides, so x equals 2. 2 is the number that needs to go in my little box. So I'm going to go ahead and make my little box right here and put a 2. Okay, now all I'm worried about is the coefficients. Now here's what I want you to notice. Is this in standard form? And the answer is it really is. You've got third, and then you've got first here, and then you've got 0 power, okay? The issue is I want you to notice that there's nothing to the second power. There's nothing to the second power here. So here's what you have to do with synthetic division. Again, this is a little bit different than what we had to do before, but you have to put a placeholder, okay? So again, all I'm worried about here is I'm worried about the coefficients. I'm worried about the 2, worried about the negative 15. I'm worried about a positive 23. What can I put here as a placeholder? I don't have any x squared terms. So very simply, my placeholder here would be a 0, okay? So when I write down my coefficients, I'm going to bring down the 2 just like it is. I'm going to bring down, instead of the negative 15 next, I'm going to bring down a 0. That's going to kind of act as a placeholder. Because remember, it's going to put my answer into the form that I need it to put it into, okay? So I'm going to put a 0 as a placeholder, then I'm going to put a negative 15, and then I'm going to put a positive 23. And that's it. Now all I have to do is make my line. Again, leave yourself a little bit of room here to be able to put some numbers in. And the first thing I'm going to do with this particular problem is I'm going to go ahead and bring down my 2, okay? So now I have, and let's do this in this way. I've got 2 times 2, which makes 4. And again, what am I going to do? I'm always going to add. So 0 plus 4 equals 4. Now I'm going to take 4 times 2, which is going to give me 8. Negative 15 plus 8. Remember, I'm still adding everything on this line. Negative 15 plus 8 is a negative 7. So now I'm going to take the negative 7 times the 2, which makes a negative 14. And again, I'm adding. So 23 minus 14 is going to give me 9. So again, all I have to do when I rewrite my problem, remember this was, and I'll just do this for memory, this was x to the third, this was x squared, this was x, and this didn't have an x at all, okay? So when I bring those down, I'm actually going to go down by 1 on everything, okay? So instead of 2x to the third, it's going to be 2x squared plus 4x minus 7. And what is this 9 out here? Yes, you guessed it. That is my remainder. I've got a remainder of 9. So again, this is it's a lot quicker in my mind than trying to do the long division. It takes a little bit of practice. It takes a little bit of practice to get used to it. Again, if you get into this and you really have struggles and you're like, I don't even know where to start, make sure that you, one, go back and listen to the video again. But if you still need help, reach out to me and Miss Willer. We'd be more than happy to be able to help you with this actual process. So have a great day today, and we will talk to you soon.